Okay, we have to mark exercise 12. And you did B first. It was x squared greater than or equal to 25. Okay, very important. There are two ways that we can do this sum. It's not the more correct way, but the general rule that we learn is that when I have an x squared, I want to get everything on one side and 0 on the other side. That's the safer way to go. So it would look like this, x squared, the pedal, won't you switch off that backlight? Minus 25 greater than or equal to 0, and then it's in standard form, and then I can get my intercepts equal to 0, so it's going to be the difference of two squares, bracket, 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 x, x, and 5 plus and minus, and then I've got x equal to negative 5 and x equal to 5. The other way that you can do it, and that's the shorter way, but you must just remember everything, and that's saying I take the square root on both sides, and then x will be, we're going to say it's equal to 25, take the square root, and then x will be equal to plus or minus 5. But you must remember the plus and the minus. Okay. So it's fine if you choose the short method, but you must have both values. Okay. I told you guys that you don't have to draw the graph because we've standardized it. We've said I'm always going to make it positive, so it's always going to be positive, negative, positive, because that's what the graph will look like. And then the question asks for greater than or equal to, so it will be the outside values. Do you agree with that? But you can draw the graph just to visually see it and know whether you're right. So remember we said we are asking which inputs will give me a greater than 0 outcome. So which x's will give me a positive y? Here y is positive. Remember there's a y-axis. Here the y-axis is positive, here it's negative. So here all the values smaller than negative 5 and all the values greater than 5. Do you see the answer is interrupted? So therefore I have to write the answer separately. I'm going to say x must be smaller than or equal to negative 5 and x must be greater than or equal to 5. Who got it right? Good. So you all understand it, ne? Sure. The next one you had to do was E. The x squared is positive. Everything is on one side, 0 is on the other side, so I'm happy with that. I need to get the places where it cuts the x-axis. So I'm going to take out the x in common, then I'll have x minus 1. Did you remember that way of factorizing? We had the same one yesterday and we spoke about it as well. So my two answers will be x equal to 0 and x equal to 1. You don't have to draw the sketch or the diagram, but you can. It's at 0 and at 1. The graph is always positive. It's positive here, negative, positive. So therefore they're asking greater than or equal to, so it's going to be x smaller than or equal to 0, x greater than or equal to 1. Got it right? Ooh, why so few hands now? Where did you slip up? Nandi? Oh, okay. The Peru? Okay. Do you all understand it? Are you sure? Okay. Then we had J. I'm going to do J on a new page. Can I page? Oh, yeah. Oh, okay. I'll do that. Oh, yeah. Okay, 2x squared minus 5x minus 3 smaller than 0. This graph is in standard form. Do you agree with me? And it's positive, so that's what I want. I'm going to factorize it. I'm going to use the short method, not the formula. So I want factors of 2 and 1 and 3 and 1 because they are prime numbers. That's why I decided to choose this method. I have to subtract them to get 5. And 2 times 3 is 6 and 1 times 1 is 1. So it's an easy one. So I'm going to say 2x and x, and then 2 has to multiply with 3. And I want it to be minus 6 so that I get minus 5. So it's minus 6x plus 1x. Then I'll have the answer. Do you understand that? If you use the formula to get the answers, it's fine as well. X is going to be equal to negative a half, and x is going to be equal to 3. I draw my diagram. Negative a half and 3. It's always a positive graph. Okay? But now the question asks smaller than 0. So it's going to be the negative part, the middle part. Now I write the answer as 1. X must be greater than negative a half, but smaller than 3. And the answer must be together. We got it right. Ooh, very, very few. Once again, I only gave you a few of the sums. You can go and do the others again. You're going to have to. Can I page? Okay, we spoke about this one yesterday. I told you that you can get your x-intercepts very easily because they already did the factorization. So it's going to be x equal to a half and x equal to negative 3. That part is easy. If I were to snarvel this thing, no, this one, it would look like this. X plus 3 minus 2x squared minus 6x. Right? And that would be negative 2x squared minus 5x plus 3. That's what it would look like. So can you see that this is in fact a negative graph? Okay. So because of that, and you should have recognized it there, because one of your x's has a minus in front of it, and that makes it negative. So either you had to snarvel it back, and then say, right, I'm going to multiply with a negative everywhere to get it to be 2x squared plus 5x minus 3, and then my sign has to turn around. Or what would have been fine is if you noticed it and you knew they are actually asking because of the negative, therefore it's that thing greater than or equal to 0. That's what they are asking you. Now let me explain this to you. If you take this negative graph and you factorize it, you get those 2 points, right? If you factorize this one, factors of 2 and 3, that will give you 5 when you subtract, it's going to be exactly the same answers. You're also going to get 2x and x, and it's going to be 3 and 1, and it has to be plus 3 minus 1. So it's going to be 2x squared, and then 6x minus 1x is 5x, and then minus 3. So you have the same answers. X equal to a half, x equal to negative 3. Now, what happens here is with these graphs, at negative 3 and a half, the graph will cut. Now, when it was a negative graph, when it was that graph, the graph looked like this. Doesn't matter where it turns. between those two values, they are negative. When we take a look at the positive graph, this one, it will have this exact same intercepts, but it will be a smiley face. Okay? Do you agree with that? Now when I look at the negative one, they are asking where this graph is smaller than or equal to. So it's going to be here and here. All the values smaller than -3, all the values bigger than 1/2. When I look at the positive question, it's asking where that graph is greater than 0. So it's a pink graph, so it's here and here. So can you see my final answer is the same. Doesn't matter if you use the negative graph or if you use the positive graph. Do you all understand that? So it's your choice, but this one was just tricky to know, to recognize the negative, and therefore to know if we're going to use only positive graphs, that they're actually asking for greater than or equal to. Now when they ask for greater than or equal to, when I refer to the positive graph, it's these two pink ones. And therefore I know it has to be written separately, so I'm going to say x smaller than or equal to -3 and x greater than or equal to 1/2. Do you all understand that, grade 11s? Alright, at K, that one has not been factorized because the other side's not 0. So you had to go and snarvel it out. Okay, so I multiplied it out. X times x is x squared. X times -4 is -4x minus 3x is -7x. -3 times -4 is plus 12. That 12 comes over, it subtracts, and therefore it's gone. So I've got x squared minus 7x greater than or equal to 0. It is in standard form, it's positive, no problem. I get my 0 points. It's x minus 7 equal to 0. So x is going to be equal to 0, or x is going to be equal to 7. You can draw the diagram, 0 and 7. It's always a positive graph, and they're asking greater than or equal to, so it's the outsides, and therefore x has to be smaller than or equal to 0, or x has to be greater than or equal to 7. Happy? M? Okay, this one is not in standard form. They're not all on the same side, and it's not a 0 on the other side. So I'm going to take all of them to the right hand side. And then I have this sign, and on this side I have a 0. So it's 2x squared minus 3x minus 9. Do you all understand? Okay, I'm going to get my answers. Bracket, 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 bracket equal to 0. So factors of 2 and 9. That will give me 3 when I subtract them. So 2 times 9, that's not going to work. 2 times 3 is 6. And 1 times 3 is 3. And 6 minus 3, that will give me 3. So it's going to be 2 and 1. X and X. And it's going to be 3 and 3. Now I just have to check my signs. I want to get -3. So I want the 6 to be negative plus 3. So it's going to be negative there and a plus there, because 2x times -3 will give me -6. Okay? So my points will be x equal to -3/2 and x equal to 3. Don't have to draw this. There's a 3. It's always a happy graph. What are they asking? Where is it? Smaller than 0. So it's the middle part. So I say x greater than negative 3 over 2 and smaller than 3. Do you all understand? Okay, if I look at n, I can just give the answer. We spoke about that one yesterday. Where is x squared plus 4 greater than 0? X, an element of real numbers. It's always greater than 0. And then O, where is it smaller than 0? No real answer. There's no place where it's smaller than 0. Are you happy with that, grade 11s? Okay. With that, we are done with module 2 and with the equations. We are now going to start with number patterns. The linear number patterns is Tn equal to Bn plus C. We know that B is the constant difference. C is what term 1 needs. No, what B? C is what B needs to be term 1. Okay, this is a grade 8 example actually, ne? So we find our constant difference. It's plus 5 plus 5 plus 5. Then we know Tn is going to be equal to 5n. And then what does B need to be the first term? Minus 3, and there you have the formula. And then they can ask you to calculate term 10 or 100. Then you're going to say 5 times 10 is 50 minus 3, and then your answer is 47. Or they can tell you that term, a certain term is equal to, let me just quickly work one out. A certain term is equal to 992, and they want to know what is n, which term is it. Then we're going to say 5n minus 3 is equal to 992. You take the 3 over, it's 5n equal to 225, and then n is going to be equal to 199, the 199th term. Do you all remember this? Okay, we don't need to practice it. We've done many of them since grade 8. We're moving on to the grade 11 number patterns. Now the big difference between the linear, or how you know it's not a linear number pattern and a quadratic number pattern, is when you find the difference between these numbers. We call this the first difference. So we say when the first difference is constant, the same, then it's a linear number pattern. But when you find the differences and there's not a constant difference, and you take the differences between the differences, we'll get the second differences. You're going to see an example now. And they are constant. then we're going to know it's going to be a quadratic number pattern. So let me show you. Let's say I have let's just write quadratic. There's my number pattern. I find the differences here. And so the difference from 2 to 5 is going to be plus 3, plus 7, no, plus 5, plus 7, and then plus 9. This is the first difference. Can you see there's no constant difference? It's not constant. Now I'm going to take the difference between these differences. So I'm just doing that again. And then from 3 to 5 it's 2. From 5 to 7 it's 2. From 7 to 9 it's 2. And this is the second difference. Now because of the second constant difference, that indicates that it's a quadratic. Now can I show you something very interesting and something that you must always remember? Inside of every quadratic number pattern, this is a quadratic number pattern. Inside of it, there's always a linear pattern as well. Do you see that? If I ignore the top row, that's a linear pattern. Do you see that? Keep it in mind. There's a linear pattern. There's a quadratic pattern. So they are linked to each other. And therefore, when we had the linear formula, it looked like this. Bn plus c. And all that the quadratic pattern gets added to is an squared. Does that look familiar? An squared plus bn plus c. We had something like that. Ax squared plus bx plus c. Okay, it's all the same, all the same. Okay, now there's a quite a long explanation to show you how to get to the formulas that we're going to use. I'm just quickly going to show it to you here. You don't have to know it. So if we took A, B, and C, and we substituted in a 1 in n and a 1 in n, then we'd get ABC. A plus B plus C. Right? And then a 2, we'd get 4A plus 2B plus C. Then a 3, 9A plus 3B plus C, and then 4 into it, we get 16A plus 4B plus C. Okay. Then we would have our terms there in terms of variables. Then we'd get the differences between them, and then we'd get another difference. Now this first three, they will be the formulas that we're going to use to calculate the variables of a quadratic number pattern. You have to know them. Okay. So there's nothing I can do for you. You have to learn them. So at the bottom, let's say first I've got 2A, and then I've got 3A plus B, and then I've got A plus B plus C. Now can you see I've got three variables in that one, A, B, and C. And we spoke about this, I can't remember, yeah, it was when we did it, we did the simultaneous equations. We said if you've got one variable, you only need one equation. If you've got two variables, you need two equations. If you've got three variables, you need three equations. And this is exactly what's happening here. Okay. Now this first one, the 2a belongs to the second difference. And then the 3a plus b, that one belongs to the first difference. And then this third equation, that belongs to the first term of your pattern. Do you understand that? Okay. So what we're going to do is we're going to write these equations here. We say 2a equal to 2. 3a plus b equal to 3. A plus b plus c equal to 2. Now if you look at that, is it possible for us to solve that first one, a plus b plus c equal to 2? It's not possible for us to start there. It's not possible for us to start there because it's two variables. We can only start at the bottom. And then we'll say 2a is equal to 2. How do I get a alone? Divide with 2 on both sides, so a is going to be equal to 2. To 1. Okay, now I've got a. So now I can go and calculate 3a plus b, because I've got a's value. So I use that a value. I say 3 times 1 plus b is equal to 3. What is 3 times 1? And when I take it over to the other side, I have to subtract it, né? So b is going to be equal to 0. And now I can calculate the a plus b plus c. Because a is 1, b is 0, c is what I want to calculate, and it's equal to 2. So the 1 can go over, it subtracts, so c is equal to 1. So therefore, the equation for this quadratic number pattern is going to be a's value is 1. So it's n squared. There is no b value, and c's value is 1. So it's Tn equal to n squared plus 1. Was that difficult? No. So all you have to do is you have to know those three. Can we do another example? Okay, remember they are still going to ask linear number patterns in grade 11. So you can't just decide it's going to be a quadratic number pattern. You have to go check first. So we're going to start and we find our first differences. So from 6 to 17, what is that? 11. From 17 to 34, it's 17. From 34 to 57, it's 23. So can we all agree it's not linear? If it was linear, those would have to be constant. My first difference would have to be constant. Now I take my second difference. What is 17 minus 11? 6. What is 23 minus 17? 6. Can you see I've got a constant second difference? And therefore I know it's quadratic. And then all I do is I say 2a equal to 6. I say 3a plus b equal to 11. And a plus b plus c equals to 6. And now I start at the bottom and I solve each and every one of them. So I've got 2a equal to 6. A is going to be equal to 3. Then I say 3 times 3 plus b equal to 11. 3 times 3 is 9. I subtract it on the other side. B is equals to 2. And then I say 3 plus 2 plus c is equal to 6. 3 plus 2 is 5. Subtract it there. C is equal to 1. Now I can write my quadratic number pattern formula. It's Tn equal to 3n squared plus 2n plus 1. Do you understand? Okay, now do you remember with the linear patterns? Then they asked you to calculate term whatever. They're going to do it the same here. So we can say at B, they can ask you to find the value of term 100. So I'm going to say term 100 is equal to 3 times 100 squared plus 2 times 100 plus 1. So term 100 is going to be equal to 30,201. You will calculate that on your calculator, right? And then they can ask you at C, the same as with the linear. They tell you that a certain term is equal to 162. They want to know which term is it. So now I've got the answer. Can you see that? So I'm going to say Tn equal to 3n squared plus 2n plus 1 equal to 162. I take the 162 over because I need it to be equal to 0. 3n squared plus 2n minus 161 equal to 0. And now I can factorize it. Do you think we'll try it without the formula? I think not. We'll say x equal to minus b plus minus the square root of b squared minus 4ac divided by 2a. And we'll substitute minus 2 plus minus square root 2 squared minus 4 times 3 times 1, negative 161. Close the bracket, equal to 2 times 3. You all still with me? No? So I get my two answers. That's not x, that's n. So n is going to be equal to 7, or n is going to be equal to negative 23 over 3. Listen to me. Can we have a negative 23rd over 3th term? No. So it can't be that one. It's going to be the positive whole number. Can't get a negative, can't get a fraction. You can't say it's the negative 9th term. Positive whole number. That's the one. Is it difficult? No. You want to do another example? Should I take it up a notch?
Yeah, can it be decimal numbers?
No, when you have to find the number term, how many term, can only be a whole number and positive. Can't be the 9.5 term. There's not a half term. It's the term. Okay. Example 3. Okay, so what they're telling me is they're saying 6, 15x, 45 is a quadratic number pattern. I told you now, what makes a quadratic number pattern a quadratic number pattern? How do we know it's a quadratic number pattern? The second constant difference. Okay. So when you have that second difference, they must be equal to each other. Now listen to this. Do you remember equations and expressions? Equations and expressions. Expressions we couldn't solve. We can only simplify. Equations we can solve. Do I have to solve for x? Yes. I need a equation. I need a equal to sign. So I just told you that the second differences are equal to each other. So can you hear we've got an equal to sign somewhere. Now we just need to find the parts of the equations on either sides. Now let me show you. We take this number pattern. We get the first difference. Okay? How did we get the first difference with the other things? We said this one minus this one. What's the secret to mathematics? Okay, so what's 15 minus 6? 9. What is x minus 15? Thank you. What is 45 minus x? 45 minus x. Did I do anything different? No. My things are just in terms of variables. Do I know anything about the first difference when it's a quadratic number pattern? No. Don't know anything about it. There's nothing special about it with a quadratic number pattern. But with a quadratic number pattern, the second difference, that one is special. The values will be equal to each other. So let's just take one step back. We got that answer by saying 26 minus 17 to get 9. That one we got by saying 9 minus 7. By subtracting these two from each other. So why would we do something differently? We won't. Because the secret is, it all stays the same. But now, it just gets a bit complicated. So we're going to say, this one minus this one. 45 minus x minus x minus 15. Haven't done anything different. I just said whatever it says there minus whatever it says there. And for this second difference, I'm going to say that one x minus 15 minus 9. I don't have to put the bracket because there's only one term. Look at this left-hand side. The first one of the second differences. The only variable in there is x. Can you see that? And the only variable in this one is x. No. And what do I know about these two things? What do I know about the second difference? These two will be equal to each other. So there I've got an equation with only one variable and I can solve for x with a grade 8 type of solve for x symmetry. So I've got x minus 24 equal to 45 minus x plus 15. Watch the negative being multiplied in there, ne? You all still understand? I get the x's on the same side. I've got negative 2x here. I'll take it to the other side, then it will be 3x. And on this side, I've got 45 plus 15. That gives me 60. And then the minus 24 goes over. It becomes plus, so it's 84 on the other side. And then I divide both sides with 3. And then x is going to be equal to 28. And now you can go and check it. You can go and check whether your answer makes sense. So if I have 6 to 15, that's 9. 15 to 24, 28, what's it going to be? It's 13, ne? And then 28 to 45, what's that? 45 minus 28, that gives me 17. So I'd have 9, 13, 17. Well, how much more is 13 than 9? 9 to 13 is plus 4. 13 to 17 plus 4. There I've got it. Ready? Okay. Gonna do it for homework for me. Exercise 2 on page 58. I want you to do number 1 and number 2. No, not number 1. Skis. Number 2 and number 3 and the whole of number 4. So all you're going to do at number 4 is you just find that general formula. I know at number 4 it's a lot, it's 8 of them, but then when you get here on Tuesday, tomorrow, you're going to have it. Okay? So 2, 3, 4. Okay, I'll give you off. Do 4, only the first column, and also H. So I'll give you 3 off. Let me write it down so I'm not, because I'm now also confusing myself. Okay, so you do number 2 and number 3 and number 4, A, C, E, G, and H. Okay, you'll see H has a little bit of a star there. What do you call it, an asterisk or what? Because it's got a trick.